Hi, this is Dr. Shaw and Monster Puppet, and we're going to talk about that hat. Does that say, please be nice to me? It was a gag gift. Oh, God. So, in video number 1, we defined something called the area function. Given any function f, it has associated with an area function, a of x. It's defined as the area under f between 0 and x. One thing I kind of snuck in there, but that's going to turn out to be important, is a of 0 is going to be 0. Okay, that's the way it goes, because the area under the curve between 0 and 0 is 0. All right? Okay, video number 2, we showed this fact, that the derivative... Oh, and we could write the area function as the integral from 0 to x of f of t dt. That's how we can write it. We showed that the derivative of that, so the derivative of the integral from 0 to x of f of t dt is f of x. I'm going to show you now how we're going to use that to evaluate integrals. So if you have any integral, which is the area under a curve, we're going to be able to figure it out using a wonderful trick that comes from the Fundamental Theorem of Calculus. Let's do an example. A weird example. Yeah, a weird one. Yeah, weird. All right, so let's look. I want to know the area under the curve sine of x plus 1 between 0 and 5. Not weird. All right. It's harder than we've been doing. Okay, but not weird. Yeah. I don't really enjoy weird, says the man to the puppet. Okay. I want to know the area under the curve of sine of x plus 1. Okay, so here's how we're going to do it. I'm going to find the integral from 0 to x of sine of t plus 1. And then I'm just going to let x equal 5, and that's going to give me my area. Right. So the derivative of what I want is going to be sine of x plus 1. That's the Fundamental Theorem of Calculus. So I need to figure out a function whose derivative is sine of x plus 1. Well, I know if I take negative cosine of x, the derivative of negative cosine of x is positive sine of x. The derivative of x is 1. So I have negative cosine of x plus some constant. Because any constant he puts in there, the derivative is 0. So that'll work. Yeah. What should the constant be? Well, when I plug 0 into that thing, I want to get a 0 out. So negative cosine of 0 plus c has to be 0. That's because the area from when you let x equal 0 is 0. So negative cosine of x is negative 1, so c is positive 1. So my answer is going to be negative cosine of 5 plus 1. Okay, let's put it all together. And ignore the fact that everything in the room just changed around. A simple explanation, I had my laptop and my microphone on the cat tree, and then I went to get a cup of coffee, and the cat wanted the cat tree and knocked everything over. It's too bad you missed it. It was mayhem. I wish the camera was rolling. How do we find the integral from 0 to x of f of t dt? This is the area under the curve f of t from 0 to x. First thing we do is we find a function whose derivative is f of x. And that's called the antiderivative. Yes. And so what we're going to do is we're going to find a function whose derivative is f. We call that the antiderivative. We usually write a capital F to make it anti. Whatever. So you find the antiderivative, a function whose derivative is f. Once you got that, you plug in your x, and you subtract what you get when you plug in 0. So capital F of x minus capital F of 0. So if you want the integral from 0 to 5, it's going to be capital F of 5 minus capital F of 0, which is what we did with that sine x plus 1 curve. That's all you do, right? So the capital F of 5, that comes from the Fundamental Theorem of Calculus. That capital F of 0 comes from trying to get the right constant. But that's all you're going to do. So it's going to be capital F of the number you want minus capital F of 0. What if you don't want to start at 0? Excellent point. Then what you're going to do, if you want like the integral from a to b, it's capital F of b minus capital F of a. Again, you take a function whose derivative is what you want, plug in the b, subtract what you get when you plug in the a, that takes care of the constants, and that's how you do it. So, what do you think, Monster Puppet? I think I like the old set better. Can we reconstruct it? No, that's going to take hours. Please, please. I was looking at him. Please. All right. We'll reconstruct the old set and I'll say goodbye. All right. So thank you very much for watching this video. Thank you for putting up with this guy. Thank you for putting up with that guy. And I hope you have a pleasant day and you learned something about the fundamental theorem of calculus and bad hats. And I'll see you later.